continue talking about integrals. Today, before start calculating the arc length or length of an arc, we're going to talk about improper integrals. In next calculus class, you're dealing with series, and one of the tests of convergence of a series is using improper integrals. So what is an improper integral? Objective improper integral. Very well. Here's a question for you. Suppose I ask you to find the area below the function 1 over x squared on the right-hand side of x equals to 1. So the question is, find the area below function 1 over x squared on the right side of x equals to 1. Very well. When it comes to integrals, our very first step is to visualize what we are dealing with. So let us graph it first. Okay. This is our function, 1 over x squared, and we are just dealing with the right-hand side of the graph. So take a look at this. On the right-hand side, here you have your x-axis. Well, here you have your y-axis. And this is your graph here. And it says on the right-hand side of x equals to 1. So x equals to 1. And we want to know what is this area. What is this area? Well, okay. So as you can see, it doesn't stop on the right-hand side. It just continues. What is this area? Is this a number? Is this infinity? Since the graph continues, you might say, hey, the area is infinity, but is the area equals infinity? Because the graph continues. Remember that it just says on the right-hand side of x-axis. X equals to 1, and it continues on the right side. So how do you calculate this area? Do we say the area is infinity? Very well. So we are mathematicians. We learn about techniques of integration. Let us start calculating this integral. We're not just relying on visualization and say, hey, based on the visualization, based on the intuition, we can calculate the area and it is infinity or it's not infinity. Let us actually calculate this area. So we know that the area is equal to the integral. There is this function, 1 over x squared. We're going to write this guy down, 1 over x squared. And since we are taking the integral with respect to variable x, we use dx. On the left-hand side, we have 1. And on the right-hand side, we have infinity. Let's see. Infinity. I have Other colors, infinity. So these types of integrals are called improper integrals. One of the boundaries or both of them are infinity. So how do we write this guy down? We write it this way. We say, hey, this integral is equal to, since here you have infinity, your upper limit goes to infinity, approaches infinity. So recall, when it comes to approaching infinity, you're getting back to elementary calculus, the concept of limit. So we're going to write this as the limit. Okay, nice. Limit of the integral 1 to L while L approaches infinity. So instead of having upper limit as infinity, we're going to write it as L approaches infinity. We calculate this integral, then we take the limit. Okay, here you have 1 over x squared dx, which is super easy for us to calculate this integral. Very well. This is 1 over x squared, x to -2, so you get -1 over x. This is the limit of L goes to infinity of -1 over x squared over x to the first. X starts from 1 and stops at L. So let us plug in L, let us plug in 1, and then take the limit. So here you have the limit of while L goes to infinity. So -1 over L minus -1 over 1. Well, negative and negative, it is positive 1 plus 1. So what is this limit as L goes to infinity? As L goes to infinity, -1 over infinity, this is just 0. So what is this limit? This limit is equal to 1. But what is this guy? This is the area. So the area is equal to 1. This area is equal to 1. Note that this little areas here, they're getting smaller and smaller. They're approaching to 0. So we expect this area to be a number, to be a nice number, which calculation shows that it is equal to 1. Well, what if I ask you to find the area below y equals to 1 over x on the right-hand side of x equals to 1?